Have you ever thought about traveling back in time to change your past or leaping forward to see the future? Time travel, a concept that has long captivated our imagination through science fiction, might not be as far-fetched as you might think. Theories in physics suggest that it might be possible to bend the fabric of time, to loop back or spring forward. This idea, once confined to the realm of fantasy, is now being seriously considered. Time travel, once a fantasy, may be more plausible than you think. The concept of time travel originates from the realm of theoretical physics. It's a captivating idea, isn't it? The possibility that we could leap forward or backward through the ages, experiencing different eras and glimpsing what's yet to come. But how could this supposedly occur? This is where Einstein's theory of relativity steps in. It suggests that time isn't a constant, unchanging entity. Instead, it can stretch and compress, much like a cosmic rubber band. This phenomenon is known as time dilation. Essentially, the faster you move, the slower time passes for you relative to a stationary observer. So if you were to zip around the universe at the speed of light, you'd age slower than your friends back home on Earth. But there's another intriguing aspect of time dilation. It doesn't just depend on speed, but also on gravity. The stronger the gravitational field, the slower time ticks. This leads us to the edges of black holes, where gravity is so intense that time slows down significantly. Theoretically, if you could hover near a black hole without falling in, you might witness the universe aging rapidly outside your spaceship window. However, achieving such feats would require technology and energy beyond our current capabilities, not to mention surviving the immense gravitational forces without turning into human spaghetti. So, in theory, time travel is possible, but what about the practicality of it? Enter wormholes, a theoretical passage through space-time that could create shortcuts for long journeys across the universe. These fascinating constructs are not just a science fiction trope, but a serious subject of study in the field of theoretical physics. A wormhole is like a tunnel with two ends, each at separate points in space and time. They could potentially allow for faster-than-light travel, something currently deemed impossible by our understanding of physics. Imagine this: you enter a wormhole, and in the blink of an eye, you've traversed light years of space, arriving at a distant star system in no time at all. Wormholes are deeply rooted in Einstein's theory of relativity. In fact, they're also known as Einstein-Rosen bridges, named after Albert Einstein and his collaborator Nathan Rosen. These bridges connect two different points in space-time, and if they are stable enough, they could theoretically allow for time travel. But don't pack your bags for a time travel vacation just yet. There are still considerable challenges, including the stability of these wormholes and the enormous energy required to keep them open. Not to mention, we haven't actually observed any real wormholes yet. They've been portrayed in countless movies and TV shows, from Interstellar to Star Trek, capturing our collective imagination and driving scientific curiosity. Wormholes could be our ticket to not only traversing vast cosmic distances but also time itself. However, as tantalizing as these theories are, they come with their own set of challenges and controversies. When we venture into the realm of time travel and wormholes, we inevitably encounter a healthy dose of scientific skepticism. After all, these concepts are not just mind-bending, they're potentially universe-altering. Firstly, let's talk about the energy requirements. To create a wormhole, according to Einstein's theory of relativity, we would need an enormous amount of energy. More energy than 1,000 suns could produce in 1,000,000 years, and we haven't even started discussing how to keep a wormhole stable. Theoretical physicists suggest the use of exotic matter with negative energy density, but this is purely hypothetical and has yet to be observed in the physical universe. Then there's the issue of paradoxes. The classic example is the grandfather paradox. What happens if you travel back in time and accidentally prevent your grandparents from meeting? Would you cease to exist? These paradoxes create logical inconsistencies that make time travel a complicated affair. Finally, the elephant in the room: the lack of empirical evidence. Despite numerous claims and anecdotes, there's no concrete proof that time travel or wormholes exist. This doesn't mean they don't, but it certainly fuels skepticism. While time travel and wormholes remain largely theoretical, their study continues to push the boundaries of our understanding and spark our collective imagination.